Hello everyone, my name is Luke and together with Dylan, Minos and Matthijs I will be presenting our project about Firefox. Firefox is a free and open source browser by the Mozilla Foundation. It is available for all major operating systems in over 96 languages. It was first released back in 2002 as part of the Mozilla project with the goal of providing people with the best browsing experience whilst putting the user in control. Nowadays, Mozilla Firefox is trying to keep the web a healthy place and commit itself to the interests of the individual. Next, let's delve into the architecture of Firefox. Firefox has a highly layered architecture where on the lowest level every component has a single goal. Each component is designed to limit inter-component dependencies. This design choice makes it easy to revise components while influencing other components as little as possible. The highly layered design of Firefox does make it difficult to comprehend the system as a whole, but this drawback is outweighed by the ability to develop components individually. Because of the size of Firefox, we can't delve into too much detail when listing the components of the project, so we will stay at a high level. Desktop Firefox contains modules related to the desktop browser. Unsurprisingly, mobile Firefox contains modules related to the mobile browser. Some of the modules that are used by both desktop and mobile comprise the toolkit. Then Core contains many modules that are also shared with other Mozilla projects. Most Firefox modules in Core are backend modules, such as Gecko and SpiderMonkey modules. Testing describes all testing resources, such as unit tests or the try server. And finally, the developer tools are tools like the Page Inspector and the Network Monitor.
Gecko is the browser engine of Firefox. The browser engine is responsible for rendering the web pages that the user wishes to visit. The Gecko engine is also used to draw most of the interface of Firefox. The use of Gecko to render the interface makes it easy to create a cross-platform browser that is easy to maintain. Firefox is multi-process. It uses multiple copies of the browser engine that communicate using IPDL or Inter-Process Communication Protocol definition language. Before Gecko can render a web page, the web page must be obtained from the network. This is where Neko comes in. Neko is the networking component of Firefox that handles all the network requests. To develop new code and to maintain high-quality code, a combination of the development and testing processes are used in the development of Firefox. Dylan will tell you more about this.
First, we will take a look at the CI process. The continuous integration process for a bug report or feature request can be seen on this screen. Note that Firefox uses Mercurial instead of Git. The process starts when someone files a bug report on Bugzilla. Interested contributors can then discuss a code change and assign a priority. Next, the issue is assigned to a developer, who can then write a solution and test it locally. Testing the patch on the try server is common, but it is also optional. Then, the solution patch is submitted to Fabricator, where it can be reviewed. If a try server job fails, or the review requires a rewrite, we go back to the Write Solutions tab. Finally, if the module owner or one of his or her peers accepts the patch, it can be merged into Central. Next up, we will look at the testing processes. Firefox has an enormous codebase and targets many platforms. To make it easier for contributors to test changes, they can push patches to the so-called try server. The try server builds and tests different configurations on a multitude of platforms. A lot of testing frameworks are used for all of the different test suites. In addition, a lot of linters are run because the code is written using various programming languages. There are also tools that allow for fuzzing, for performance testing, and determining code coverage. All of these can be run on the try server. After each release, an automated process publishes the unit test coverage on a public website. A screenshot of this website can be seen on the right. The testing coverage has been stable around roughly 63% for the past few months. It is not higher because it includes many development tools that are not shipped with the product. For example, the security component only has 44% coverage, but if you exclude the network security services tools, it achieves more than 80% coverage. Next up, we will look at the variability of Firefox, which we chose as the topic of our final essay. Firefox has many options for customization, configuration, and extensions provided by its variability features.
Some of the variability features that support customization, change, and addition are the profiles. Another example of variability in practice are the different versions, including the default, nightly, developer edition, Tor, and many others that have been developed over the years. We'll first go into detail for the profiles and then continue with the versions. A Firefox profile consists of multiple files. These files mostly contain information that is relevant to the activity of the user that is connected to this profile. Some of the files that are stored inside each profile include the user's preferences, along with things like the different add-ons, passwords, and cookies of the user. Changes to these files take place whenever a user performs an action. For example, whenever the preferences of the user's profile are changed within a browser session, the file inside this user's profile changes as well. Add-ons are one of the main features that allow the user to enhance the performance, security, functionality, and appearance of the browser. There are three types of add-ons: extensions, themes, and plugins. Some examples of extensions are ad blockers, password managers, and tracking protection mechanisms. A custom theme can be selected for a more personalized experience. Last but not least, multiple plugins can be downloaded, such as text readers, video players, and many more. As mentioned before, we will also take a look at the different versions of the Firefox project that are deployed. The default version is the simplest and most user-friendly one. It is used by users that need the browser for regular use. Nightly and Developer Edition are very similar to the default version. However, they include new features that are not officially released yet, so they are less stable. This is why, if agreed by the user, Nightly collects anonymized information for debugging purposes. Nightly Edition updates nightly, as the name suggests, thus it is the most unstable version. Developer Edition is specifically designed for web developers in a way that it has JavaScript debuggers and multiple tools that a user can utilize in order to identify issues. Finally, Tor browser is a fork from Firefox's source code. For its implementation, many preferences have been changed from the default version. Some patches have also been applied in order to enhance the security and provide a higher degree of untraceability. In this presentation, we discussed the main architectural components of Firefox, its continuous integration process, as well as the testing coverage of the system. We talked about the main variability features and how these allow for more customizability and accessibility of the browser. If you would like to see more, please visit our page on the course's website.